Personal opinion, logs aren't hard. It just gets confusing remembering which one's the y, which one's the x, which one's the b. And so it's a matter of, what's the right word for it? Just kind of slowing down and thinking about, that's why the homework last night was just putting the y equals x so that you get used to it's y equals x kind of format. But honestly, that's probably the hardest part. So no, I don't think it gets harder. And we have it broken down, so it's all good. All right, so, but today we're going to put it into like numbers instead of just the y equals x, so that we have a little bit more where we can actually apply it, okay? So remember last week we did that bacteria in the swimming pool thing, and we found that there was like, I don't know, 3 million in the thing, and we used this equation, okay? And so why do you think that equation is going to be equivalent to this equation? Why are they the same? Ooh, good thought process, but you're making it more complicated than it is. Because think about with this equation here. If I divided 3 million, because that's 15,000 times 2 to the t, right? If I want to undo that multiplication and I just divide each side by 1,500, okay, I'm going to end up getting 2,000 is equal to 2t. Okay? And that's kind of what we're doing when we're moving stuff back and forth between exponents and logs. We're just going to be undoing different stuff. Okay? And so we didn't really, I mean, we used our calculators to solve it, but what we're going to do is sometimes you get those exponential equations that you can't solve, okay? And so what we're going to do is learn how we transfer that into a log, because then we can solve it, okay? All right, so we have our two definitions, okay? These are the key things that we want to keep in our mind, and this one's our exponential. And obviously this one's the log, since it says log. Okay? And if we do our definition, okay, and now we want to put, last night we would have had like 10 and then x and then y. If I want to put that into log form, okay? All right. My base is 10. Would you agree with that? Okay. My x basically is 2. Would you agree with that? And my y is basically equal to 100. So that means that I can rewrite it as log base 10 of 100 is equal to 2. Does that make sense? Okay, our 10 is the base in both the exponent and log. And the log, we have the exponent. How many exponents, how many times do we raise 10 to get to 100? Okay, so that's kind of like, it's like reversing that y and x. Instead of thinking, what's the answer of y? It's thinking, here's y, what's the answer of x? Okay? All right, so if we have 6 squared equals 36, we all agree with that one, right? Okay, so to rewrite it as a log, I would have the log, if I'm using a base 6 of 36, means my exponent is 2. Does that make sense? Okay, and the one that didn't print was 2 to the 5th equals 32. So what's my base going to be? Can you guys all see that okay? This is a 5, 2 to the 5th, I'm sorry. So what's my base? 2. And what's my y? The 32. And that means my exponent was 5. So if I have a log base 2 and my answer is 32, that means I raised 2 to the power of 5. Good. Okay, so now let's flip back to exponents. All right, so for the first one, what's my base going to be? Because remember, if I want an exponent, I want y is equal to b to the x. So what's my base? 4. And what is my x? What's my exponent? And the y then is 16. So to rewrite it, I would have 4 squared equals 16. Make sense? That's the part that I think it gets tricky, flipping back and forth between the two and remembering which is my x and which is my y. But if you just kind of think about it as, well, what am I going to do to 4 to get to 16? Raise it to the second power, right? Okay, so what's the next one going to be? What's my base going to be? 6, right? My exponent's going to be 0. And does that equal 1? Yeah, because anything raised to the 0 power always equals 1. Okay, good. All right, so the last time, and sometimes we just have different variables, and that's okay too. So what's the base going to be?
3.
And my exponent's going to be t, and the answer, or y, would be n. All right, and the reason why we like doing this is because if I have a problem like this, log base 9 of 81 equals x, and I need to solve for x, I have no idea what log base 9 is, so I can just set it up into an exponential equation, okay? And so one way to think of it is that it's like kind of going around a circle. So I go this way to x, and then I end up at 81. Now I can solve for x, right? How many times do I have to raise 9 to the power to get 81? So that just means x is 2. See, not that hard, right? Okay, so my base is 8. I'm going to go around. I got 3 as the exponent, and x is my y. So what's 8 cubed? Anybody remember off the top of your head? When this on your list of, what's 8 times 8? 64. What's 64 times 8? Can we do that in our head? How about 512? But close. You got the 12. That's half the battle. All right. The next one that didn't print again is log base 5 is or times 3x plus 1 equals 2. Can you guys read that okay? Log base 5, 3x plus 1 equals 2. Doing the exact same thing. All right, my base is 5. I'm going to go around the circle, add the 2, equals 3x plus 1. Now that looks simple, because 25 equals 3x plus 1. Subtract 1 from both sides. Divide by 3, and I'm running out of room, and x is going to equal 8. Good? Easy peasy? So what do you think? Is it getting harder? No, it's not. All right. Try these 3. Okay, I'll give you a minute, and then we'll check and see how we did. Is that what you guys are getting so far? See glass ahead? Yes. Awesome. Good. Feeling okay about those? All right. Then, okay, so basically any positive number can be a base, okay, except for 1, which we're going to talk about later on. That's like the one exceptions, okay? And if it's a 10, so like if it's a log base 10, okay, those are called common logarithms. okay? Because think about it, our number system is based on 10, right? That's the common use of measurement. So that's why it's a common log. And they're just, you just write them as like log y equals x, okay? You don't have to put the base 10, okay? And your calculator is automatically programmed for base 10, all right? So if we need to evaluate log of 78, okay? There's no base, which means we're using base 10. So if I wanted it as an exponential, I would write it as, so I would have log 78 equals x, right? That would mean as in, I would have 10 to the x is equal to 78, right? I don't know how to do that. I don't know how many times I got to bring 10 to the power, but the calculator will do that. So if you notice, you have a log button, okay? It's set, that log button is set to a base 10. So all I have to do is press the log button and put in 78, and that means my exponent is 1.892 blah, 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 blah. Okay, so that means that 10 raised to the 1.892 blah, blah, blah is going to give me an answer of 78. That's not something I can do in my head. Okay, that's why logs are so helpful. Okay. All right. If logs use the irrational number of e, remember we talked about e at the beginning? Okay. These are really important when you get into, did you guys say chemistry was using e? Okay, well physics uses it a lot too, okay? And you'll end up using logs in that too, and that symbol is really actually a number, okay? And it's 2.718281828 blah blah blah. Okay, so if you have a function or if you have a log where e is the base, okay, that's called a natural logarithm. Okay, and if you don't want to write out the whole log base e of x, they have a shortcut, and it's just ln. Oh, I'm sorry, my bad. Okay, and that also is programmed into your computer. Okay, if you look at the calculator, if you look at the see how you have your E button here? There's also an LN button. Okay? So, if you want to find out what the LN of 126 is, what do you think you need to do? Is put in LN 126, which is going to give you 4.836. Okay? But what's that number mean? What did we just find other than the ln of 128? Okay? That's where it kind of gets into the confusion. And so in order to make sure we know what we're finding, sometimes it's easier to put that base in. So I would have had the ln with a base e. My answer is 126 would be equal to x. So that meant that e to the x is equal to 126. So what I found was the exponent for e. That would give me the 126. Does that make sense? Yes? All right, so if I want to solve for x, okay, the way it's looking right now, I'm not quite sure how to do it. And this is where you want to flip back and forth to which is easier. Well, if I say, hey, I have a log base e, and that's equal to 7. Can you guys see that okay? Then I can put that back into exponent form. E to the 7th is going to equal my x, right? Now I can solve it because my handy dandy calculator has an E button. It's the second, I have the blue, so I have to hit my blue button, and then the ln, I can put 7 in for my exponent, and I get that x is equal to 1096.63. Okay. All right. If you have an e where x is the exponent, this is where you want to flip back to the ln, because if I say, okay, well, the log base e of 85 is x, and my shortcut button on the calculator says ln of 85 equals x, now I can plug and chug, hit my ln, and 85, and x is equal to 4.44, blah, 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 blah. And that's the tricky part. Knowing when, or remembering when to flip to exponent, when to flip the log, and which one to use. But that's not bad. The more we practice, the better we do. Okay? All right, so let's think about something. If I want to evaluate the log of 10, okay, what's my base? Do I have a base written down? It's 10. It's not showing, so it's 10. So if I just put in log of 10, I get 1, right? But doesn't that make sense? Because if I'm base 10, to write it as an exponent, my base with my exponent is going to equal 10. Does that make sense? And if we do the same thing with E, if I evaluate out the ln of E, I'm going to get 1, because it's the same thing. I'm doing a log base E of E equaling 1, put it back into exponent, E to the first is going to give me the same number back. So if you get 1 as an answer, it's okay. But that's why you can't have 1 as a base, if that makes sense. Okay? Good. Have I made your heads explode yet? Not yet? We're doing okay? All right, so we've got like 15 minutes left, and I have somewhere in here. Huh? Let me find